Fresh cassava roots arrive for large-scale processing. Workers guide trucks into the unloading position. Cassava roots are discharged into the intake hopper. Initial separation removes large debris. Soil content is assessed during intake. Roots are transferred to the cleaning line. Defective roots are manually removed. Automated conveyors maintain continuous movement. Digital systems track processing efficiency. Centralized monitoring ensures operational stability. Roots advance toward intensive washing. Initial sprayers remove surface dirt. Vibration loosens stubborn soil deposits. Mesh systems separate fine debris. Air suction removes lightweight contaminants. Roots undergo deep immersion washing. High-pressure jets strip away embedded dirt. Rotating paddles intensify the cleaning process. Continuous tumbling ensures uniform washing. Cleaned roots move toward final rinsing. Final spray rinsing ensures surface purity. Washed roots advance to peeling.
Mechanical peelers begin skin removal.
Rollers strip away the outer skin. Precision abrasion reveals clean white flesh. Removed skins are separated as waste. Defective roots are automatically rejected. Peeled roots receive a final rinse. High-pressure sprays ensure maximum cleanliness. Clean peeled roots move toward inspection. Laser systems inspect size and quality. Roots enter the primary cutting unit.
Cut pieces move to secondary sizing.
Precision slicers refine the cut. Operators regulate cutting precision.
Cut pieces are elevated to the next stage. Uniform cubes are discharged for sorting.
Bulk diced cassava advances in high volume. Oversized cuts are separated automatically.
Parallel conveyors balance production flow.
Processed cuts advance toward grinding. Cassava enters the crushing system. Rotary drums break down the structure. Continuous feeding ensures steady grinding. Water is added to form slurry. Crushed cassava transforms into starch slurry. Screens separate fiber from liquid starch. Refined starch paste moves onward.
Liquid starch is transferred for processing.
Starch milk collects in processing vats. Samples are collected for quality testing.
Technicians examine starch purity levels. Flow rates are monitored continuously.
Centrifugal systems extract excess water.
Purified starch continues downstream. Starch milk is stored for separation. Wastewater is separated from clean starch.
Hydrocyclones refine starch purity.
Controlled mixing stabilizes the slurry. Excess water is removed from starch.
Dewatered starch cake exits filtration.
Fiber waste and pure starch are separated. Sensors track real-time product flow. Purity levels are digitally confirmed. Quality approval enables further processing. Refined starch collects for thickening. Starch paste is extruded for pressing. Operators monitor tray filling consistency.
Hydraulic presses remove internal moisture.
Excess liquid is extracted under pressure. Compressed starch cakes emerge from the press. Secondary pressing improves density.
Moisture levels are precisely measured.
Pressed blocks are cut into sections. Cut sections move for further breakdown. Compressed blocks are broken into chunks.
Chunks are elevated for reprocessing.
Material is remixed for uniform consistency.
Inspectors verify texture and moisture.
Processing parameters are fine-tuned. Chunks enter the crushing unit. Material is reduced to granulated form. Powder texture is manually assessed. Particle size uniformity is verified. Refined powder advances to drying.
Dried powder collects in storage bins.
Powder is evenly distributed for processing.
Controlled chutes guide powder flow. Rotary systems assist drying. Powder undergoes controlled drying. Powder enters large-scale mixing units.
Heat treatment ensures microbial safety.
Heated powder exits sterilization.
Moisture evaporates during transfer. Cyclone systems refine powder flow.
Dried powder is collected in storage hoppers.
Screw conveyors regulate powder flow.
Integrated systems maintain continuous production.
Leveling ensures uniform product depth.
Automation ensures processing precision. Drying cycle is successfully completed.
Dried powder moves to final processing.
Powder is distributed across processing lanes.
Quality teams verify powder consistency. Sifting refines final flour texture.
Fine mesh sieves ensure flour smoothness.
Refined flour gathers for transfer. Multi-stage sifting maximizes purity. Measured quantities are filled into containers.
Laboratory testing confirms product quality.
Microscopic analysis verifies starch structure.
Batches are certified food grade.
Approved flour moves to packaging.
Bulk storage feeds packaging lines.
Filled sacks move for sealing. Sacks are securely stitched closed. Manual filling supports bulk operations. Each sack is weight verified.
Bulk packaging serves industrial distribution.
Sealing reinforces packaging integrity.
Each sack receives batch identification.
Packaged flour advances for inspection.
Final inspection ensures packaging quality.
Sealing edges secure the contents.
Sacks are aligned for pallet stacking.
Sacks move toward palletizing.
Robotic systems stack sacks efficiently.
Pallets are moved to storage zones.
Automated stacking maintains precision.
Pallets are secured for transport.
Wrapping secures pallets for ship. Inventory systems log outgoing pallets. Pallets are transferred to dispatch.
Shipments are loaded for distribution.
Processed cassava flour begins its journey to market.